The first support system that we choose is a fully fixed beam. A fully fixed beam is supported by fixed supports at both ends. It can resist both vertical and horizontal forces as well as moment. This beam has three unknowns at both ends. This is the idealized structure of the fully fixed beam, which shows that the beam is supported by point A and point B, while W is equal to 45 kN per meter and L is equal to 4 meters. The free body diagram of the beam shows that the beam have three unknowns at both ends. To find the value of VA and VB, VA plus VB is equal to WL is equation number 1. Assume that the moment at A is equal to 0. Moment of A, WL times by centroid of the beam, L over 2 minus VB times L. And then you will get the value of VB equal to 90 kN. To find the value of VA, substitute the value of VB into equation number 1 and you will get the value of VA equal to 90 kN.
Cable structure. A cable structure is a type of structure that stabilizes tension cable to support or transmit the major loads of the structure. Pin support resists both vertical and horizontal forces but not a moment. Allow the structural member to rotate but not to translate in any direction. Idealized structure. Free body diagram. AC squared equal to 1.5 squared plus 3 squared minus 2 multiplied by 1.5 multiplied by 3 cos 90. AC squared equal to 45 over 4. AC equal to 3.354 meter. 3 over sine alpha equal to 3.354 over sine 90. Sine alpha equal to 3 sine 90 over 3.354. Alpha equal to 63.44 degree. Beta equal to 0 minus 63.44 minus 90 degree. Beta equal to 26.56. Step 1. Give an assumption FCX equal to 100 Newton, Fs equal to 0, Fcy equal to 0. Length of AB equal to 1.5 meter, length of BC equal to 3 meter. Step 2. Find external force of Fby, Fbx, and Fay. Positive direction of Fy, sum of Fy equal to 0. Fay plus Fby plus Fcy equal to 0 in equation 1. Positive direction for sum of Fx equal to 0. Fas minus Fby plus Fcx equal to 0. 0 minus Fbx plus 100 equal to 0. Fbx equal to 100 Newton. Sum of Fb equal to 0. Fay multiplied 1.5 plus Fcx multiplied by 3 equal to 0. Fay multiplied 1.5 plus 100 multiplied by 3 equal to 0. Fay equal to negative 200 Newton. Substitute Fay equal to negative 200 Newton in equation 1. Negative 200 plus Fby plus 0 equal to 0. Fby equal to 200 Newton.
Beam bridge. Beam. Structural element that is capable of withstanding load primarily by resisting against bending. roller support only restrain the structure from moving in one or two perpendicular directions. Can move in other directions and also rotate. Pin support to prevent the structure from moving or restrain its translation degree of freedom. Idealized structure. Free body diagram. Calculation. Step 1. Sum of fx equal to 0. bx equal to 0. Step 2. Sum of y equal to 0. Negative 3 times y plus ay plus by equal to 0. ay plus by equal to 18 kilonewton. Step 3. Sum of moment A equal to 0. 3 times 6 times 3 minus by times 6 equal to 0. 54 minus 6 by equal to 0. 6 by equal to 54. by equal to 9 kilonewton. Substitute by equal to 9 into equation. ay plus by equal to 18. ay plus 9 equal to 18. ay equal to 9 kilonewton.
Now I will present on truss structure. Truss is a structure that consists of elements that takes only tension or compression. Pin and hinge connection is usually used in truss structure. It can resist both horizontal and vertical force but not a moment. In civil engineering, a truss is a structure that consists of two members only. A two-force members is a structural component where force is applied on 2 points only. This is an example of truss structure I captured from a construction site. And this is the idealized diagram of the structure. As you can see, there are two pin support in this structure. This is the free body diagram of the structure. There are two unknown at point A, which is AX and AY, and another two unknown at point B, which is BX and BY. Between point A and point B is 10 meter, and the structure is elevated 1 meter outward. And there is another uniform distributed load which added toward this structure, which is 200 Newton per meter. For the calculations, step 1. The force towards the right direction is always assumed to be positive. The summation of Fx equals to 0. So Fax minus Fbx equals to 0. There is another assumption made here. That is Fbx equals to 200 Newton. So Fax minus 200 Newton equals to 0. Finally, you will get the answer of Fax equals to 200 Newton. Step 2. The force direct outward is always assumed to be positive, and the summation of Fy equals to 0. So Fay plus Fby minus 200 times 10 equals to 0, where 10 is the length of the structure. So you will get the equation 1, which is Fay plus Fby minus 2000 equals to 0. For step 3, the clockwise direction of the moment is assumed to be positive. The summation of moment at point A is also assumed to be equals to 0. So you will get negative 200 times 1 minus Fby times 10 plus 200 times 10 times 5, where 5 is referred to the centroid of the structure. So it will get negative 200 minus 10 Fby plus 10,000. So finally you will get Fby equals to 980 Newton. The last step, substitute FBY equals to 980 Newton into equation 1. So you will get FAY plus 980 Newton equals to 2000 Newton. So finally, you will get the answer of FAY equals to 1020 Newton.
This is a pin connection structure found at Tunku Tun Amina Library. The steel column connected with pin at lower end. As we know, each pin connection can resist vertical and horizontal forces. Hence, the end of the steel column has two unknowns, V and H. Let's look at the idealized free body diagram. Some assumptions was made. As the weight of the ceiling is 500 Newton, the height of the steel column is 4.5 meter and the distance between two columns is 3 meter. Two unknown forces exist at both point A and B, the lower end of the steel column. The support reaction V and H can be determined by using these three formulas, that is, total Fx equal to 0, total Fy equal to 0, and total moment equal to 0. First, let total left horizontal forces equal to total right horizontal forces. Then we get HA equal to HB. Hence, since total Fx equal to 0, HA equal to HB and equal to 0. Then let total upwards force equal to total downwards force. Then we get VA plus VB equal to W. And that is VA plus VB equal to 500 Newton. Then we take moment at A. VB times distance B minus VW times B divided by 2 equal to 0. VB, substitute the value VB times 3 minus 500 times 1.5 equals to 0, and we get VB as 215 Newton. Then substitute VB equal to 250 Newtons into the first equations. Then we get VA as 215 Newtons. And these are the summaries of the support reactions.